I really like to understand how things work, or how, like, the beginning of things. Kind of, and why is that? And why is that? And why is that? So physics was the discipline that could answer me this question, I felt.
Welcome to the PAM Talks, a student-led podcast exploring the universe through the lens of diversity. Each episode, we interview a new mentor, showcasing the voices of researchers from traditionally underrepresented groups in physics and astronomy. I'm Pamela Freeman, a producer for the PAM Talks, and today we are re-releasing an interview from our original PAM Talks video series, which you can also go watch on our YouTube channel. In this episode, Dr. Maria Masoliver, a data scientist and former postdoctoral scholar at the University of Calgary, chats with Aya, a PhD student in mathematics at the University of Illinois, Urbana-Champaign, and a U of C math and physics alumnus. They discuss Maria's path into interdisciplinary work. In her research, she looks at systems that cannot easily be described by their parts or the sum of their parts. An everyday example is the brain. So, how do we study these systems, and how do physicists contribute to this work? Find out next.
I'm Maria Masoliver, and I'm doing a postdoc at the University of Calgary. It takes place in two different research groups, the complexity science in physics and astronomy, together with another research group, computational neuroscience.
That's very cool. Nice to meet you. And I'm an undergrad at U of C, and I'm going into my fourth year of math and physics. I'm not at all really familiar with complexity science or neuroscience, but I'm really interested to learn more from you today. What is a postdoc, and how, from all the way from high school, from like the start of education, how did you go from there to this position where now you're researching all these crazy systems and amazing things?
So from high school, I decided to study physics, and I did my undergrad in a university close to Barcelona. And from there, I went to Germany, in Berlin, and there I did also my master's. After my master's, I decided to do a PhD. And a PhD is a program that lasts, in Europe, it lasts between 3 to 5. Here, I know in North America, it lasts longer. You take a topic and like a research area, and you come up with novel results. The next step, if you want to keep in the academia is being working at the university as a researcher, not at a company, are called postdocs. You continue to do research related to your PhD or to another field, and you are a researcher.
Going back all the way to high school, how did you think physics is what I want to do, physics is what I want to go to university for?
It was tough for me because I consider myself also really into arts and literature. So it was actually a difficult question to do. First, I may not have been sure to take up onto physics, but actually, as how I am, I really like to understand how things work, or how, like, the beginning of things. Kind of, and why is that? And why is that? And why is that? So physics was the discipline that could answer me this question, I felt. It's true that it was not easy for me because when I was in high school, physics was not one of my best. So I like it, and also math. I really enjoy math too, but I had to really study both of them. It was not easy to me. I had a friend that she was brilliant in both math and physics, and for me it was like, wow, how she can, like, she would understand everything in 1 second, and for me it would take time, right? But at the end, I made it. So I thought, okay, let's go for physics and see if it's my thing. And so far, it has been.
What is it like to work in physics research? What's your kind of day-to-day like?
It really depends on the supervisor you have and how you are. So what I do a lot is I program a lot, right? Mm-hmm. So it's basically, let's try this, and if it works, good. Otherwise, I have to think about what is that I have to change so to achieve the results. Which is the story that I want to tell, and kind of go to that route, and don't, well, it happens to me a lot that I go to other paths. But I have to go back to my, okay, which is my objective, this is it. And what it really helps is to have a constant meetings with my supervisors, because sometimes you go into some route that has nothing to do with what you really need to do, or you think this is important, and then you step back, you need someone looking from the outside. So even as a postdoc, you need this person. What I like is that it's not monotonous. I always learn new things, and I can take a day or two or three to look into some other software that I think that is more useful for the research that I'm doing, and learn about it. And I don't have to explain to anyone that I'm doing this, right? It's always new inputs, and it's really nice.
I know you mentioned your work is mainly computational, but is it always that way, or is there is there some crossover between those other bigger sections?
Nice question. So there is a crossover in the sense that in complex science, you use experimental data, right, to kind of test your models. So I'm actually collaborating with a neuroscience group in Oxford, and basically they are the ones doing the experiments. They are the ones taking the data, also analyzing it. With this data, you can do a lot of analysis, and we are applying the framework that we are using to understand what is happening. And so I would say that here we have both experimental, because you need someone recording the signals of it's from mice and rats, and someone analyzing this data and then understanding what is actually happening and coming up with a model, a mathematical model that can describe the behavior that we see.
What is complexity science? How would you describe it?
So complexity arises when we cannot describe a system by the sum of its parts. So we also have to consider the interaction between the elements that form that system.
Do you have any examples of complexity that you think someone should have in mind when thinking of this field?
Actually, nature is complex. So there are a lot of examples we can say. Fish schooling, all these group of fishes, how they move together. You cannot tell how the whole thing is going to behave by just looking to a fish. So let's say you want to visit a friend from the university, and you have your car here, right? You could think, okay, I know my position, I know the house of my friend, I know more or less the velocity I would take, but it's not that easy. You have to look the traffic flow. We may have a pedestrian crossing and you have to stop. You have the stop signs. You have the lights. They may have happened something ahead of the road which will affect you later on. So all these things taken together makes like a simple task that you may think it's simple, complex. Basically, we use mathematical tools and physics tools to solve these problems. Maybe last example, and it's related to my research, is how the brain works. Like you can look at the individual components of the brain, which are the neurons, but just looking how a neuron works, it's not going to tell you how memory is functioning in our brain, or how we have free will, or you remember which movie you watched yesterday, right? You have to look it as a whole.
Even though you studied physics through undergrad and master's and so forth, you still ended up now working with biologists and chemists in neuroscience and everything. How is there this connection between the fields? I, from a naive perspective, would think there would be like this massive distinction between them, kind of working in their own realms, but it seems like they really cross together in your work.
Nature actually doesn't divide, like doesn't say a neuron belongs to the biologist. So at the end are humans who made those divisions to understand how nature works, and which is okay. But at some point those things they are mixed together. With the tools that I have, with my background with physics and math, how can I make it so we can understand, in my case, better the brain? Instead of, oh no, you studied physics, you cannot go into that area because it belongs to biologists, physiologists, neuroscientists. At the end, science, I feel it's a really interdisciplinary um, discipline and should be considered as such, and just not stick on our little boxes. You may actually be interested in both physics and biology and maths, and for going into physics doesn't mean that you will never end up studying or or working in biology, because you can start with physics and then like if you are more interested into the biology as well, do something like biophysics, which mixes the two of them, or for example also medical physics, like when you have MRI, engineers have designed the machines, but the background that is in those machines are being have been designed by physicists. Going into one area doesn't mean that you will be stuck there, that even if they pick biology or maths, they can always, if they like other stuff, they can look for the crossing point. Maybe at the end they even realize that they don't like it, but if you like it, I feel you are going to succeed. So I would always focus on what you think you should be doing and forget about what other people tell you.
That's great. Awesome.
Yeah.